for your exam board, you have to learn a set of conditions where you can approximate the binomial by the normal distribution. These are your conditions which you need to make a note of and then learn. So if x starts off being binomial, if n times p is greater than 5 and n times by 1 minus p is also greater than 5, well then you can approximate n by a normal distribution. What is the first thing that always goes in the bracket for a normal distribution?
The average or mean.
The mean. What is the mean of the binomial? I didn't actually write it down earlier, but what is the mean of the binomial? NP. So that will go there. What is the second thing that we write down in the normal bracket? The variance. Can anybody remember what the variance of the binomial distribution is? It's NPQ. Okay. So that is the new red box rule, and that is the conditions that your exam board accept for you to be able to use the normal to approximate the binomial.
So both those questions will be wrote in the exam as a binomial, and we've got to work that out. They're either...
Yeah, I mean, as we go through some examples, you'll see that if they give you a binomial question where the numbers are just so big it's going to take you 3 hours to answer the question, it's pretty obvious you've got to use an approximation. Sometimes they may tell you, and other times you might try and use the tables in the book and actually find that they've given you values that aren't in the tables. So then that's a pretty big hint. You should probably be doing it a different way. Yeah?
What's the significance of 5?
5, it's if n times by p, if we went back to that animation, they're saying if those two values are bigger than 5, then the bars of the binomial distribution and the normal curve are close enough that we can use one for the other. And that's their criteria of looking at the product of those two things. Okay, so if we go into an example, and we'll see how this works. Okay? So we'll call this example 1. We have a fair die which is thrown 40 times, and we're going to answer question first of all, which is find the probability of getting 3 6s, and we're going to do that the first time round using the binomial, and the second time round we're going to use the normal approximation just to compare our answers really. And then in part B we're going to find the probability of 10 or more than 10 6s. Right, so that's a question. For part A1, we can either use the formula that's on the board which we wrote down earlier and a little recap for the binomial distribution, or we may be able to use the tables. But let's just write the question out properly. We've got x here is binomial. It's binomial because we're doing something a fixed number of times. We're doing it 40 times. Probability of success, well, success here must be getting a 6. What will my p-value be?
No, we are putting, well, 1 over 6.
1 over 6, yeah, 1/6, okay. And x is going to be the number of 6s I get. And what I want to work out is a probability that that is 3. Probability x equals 3. So, using the formula at the very top of the board, that's going to be n, choose 3, p to the 3, 1 minus p to the 40 minus 3. And if you work that out on a calculator, hopefully we all get the same answer. Of 0.0538. Okay, so that is the perfect probability answer. That's done by the binomial. That's totally accurate. No approximations going on there at all. But in part B, in part A2 rather, we're going to now do the same thing and use the normal approximation. So all we need to do, we need to write it out carefully. We have got here in part B still that x follows the binomial distribution 40, 1, 6. If you're doing this in the exam, you're going to use the normal approximation. They will usually write the question out using a suitable approximation and justifying its use, work out. So what they actually want you to do, and you need to do in the exams, is to say which distribution you're going to use, and in the justifying its use, what do you think you've got to do there?
Explain why you chose that one.
Yeah, you've got to write down the criteria and show that it passes it, okay? So, if you say to use the normal approximation, you're going to ask yourself questions that we had earlier on in that red box rule. Is NP greater than 5? It's the first question you need to ask yourself. Well, that is 40 times by 1/6. Which is, has anybody worked it out already?
6.6 or something.
Yeah, 6 2/3. So the answer there is yes, it's met that condition. And your other one, you've got to ask yourself, is NPQ greater than 5? Which is the bit that we had before with a 5/6 there. And that works out to be 5.5. Sorry, 5.56.
Yeah.
Okay. Well, that's greater than 5 as well, so that's yes. So because of that, we can use a normal approximation. Now, I'm going to write this line down here. There's supposed to be a comma there. NP becomes normal NP NPQ. That's what we are going to use. So for the remainder of this bit of the question, we will use, say, x follows the normal distribution. NP, we worked out a minute ago, was 6 2/3. And I've made a mistake. Anybody spot the mistake I have made? I ought to have been suspicious when the answer you gave me didn't agree with the one I had written down in front of me. I have gone wrong somewhere. Done something wrong. What have I gone wrong?
You didn't Q instead of just NQ.
Yeah, that's right. Here, that other test was just NQ. Okay, not NPQ. Okay. I thought, why haven't I got 5 point something written down on my bit of paper? I've got 30. It should be just NQ.
So the
Okay.
thing at the top was wrong.
In here,
So the top box is wrong.
Red box is wrong. That one there, that's NQ.
Yeah, but then it says
the grey
N,
bottom line.
NP, and
Grey bottom
so
line.
it should be NQ on the inside.
Here,
Next
Yeah, you
one.
put MP, MPQ. Shouldn't that just be NQ?
that's right. That's the variance. The variance of the normal is NPQ. So that's right. Okay.
I know, I was justifying what you did.
Yeah. Okay. So yeah.
Oh, sorry.
Is NP there? N1 minus P or NQ, you using Qs, aren't you, instead of Ps, most of you, so that's right. Here, that's correct, okay? Yeah, the mistake was over here, that should have been just NQ. not NPQ.
So what you're about to put in that bracket's right?
Yes,
Even though the bit above's wrong?
yes,
Okay,
that's correct.
fine.
Okay. Yes, over here, this is right. This is the number that Billy said earlier, the 5 point what's it? It's 5 and 5/9 actually. Okay. Yeah, the mistake just was there. Okay, that should be NQ for the other test, which is what we wrote down earlier. Okay. So we're now going to use this here instead, and we want the probability.
33 and a third.
Sorry.
Is it 33 and a third?
Here it is, yes, okay, which is greater than 5. Yeah. So, now then we are going to work out then the probability that x equals 3. And the answer, Billy, is
10. 0.
0. Yes, that's a bit of a problem, really. The answer, of course, is 0 because it's a continuous distribution we're using now.
Do you, if you know that, do you even have to do that bit after so we can use a normal approximation?
Could you do the
just
problem?
write, can you just write 0?
No, because actually that's just not help. That's not helpful.
The probability that x equals 2 and then x equals 4 and then minus the probability that x equals 3 or something like
We're getting closer. We're getting closer.
2.5 to 3.5.
Is exactly what we do.
No.
2.5 to 3.5. So, can you get in the habit of now doing it like this? We wanted, okay, can we watch very carefully this bit? I'm going to rewrite that line, because actually that line, I don't think is so helpful. Write it down like this. We want the probability that x, under the binomial distribution, equals 3. I actually put BIN down there to show that binomial distribution, when we were dealing with that, we wanted 3. So actually what we want to do now is find the probability that it's between 2.5 and 3.5. And I'm going to put here x with a little norm down there to show that when we're doing this, changing it to normal distribution, we have got to do the probability it's between 2.5 and 3.5.
Why do you do that, sorry?
Because that's including, because the curve is a continuous curve,
Yeah.
and we're using it to approximate something that's discrete. And this process here of going like here, because it's like doing it to the nearest whole number, that is all 3. This is called the continuity correction. The continuity correction. And if you don't do that on these questions, you do lose marks. Okay, the continuity correction. It's because we are using a continuous model on a problem that was originally discrete. So,
Would you always approximate it with using the one decimal place version? So if you had one to a greater degree of accuracy, you're looking for 3.
remember, this can only be whole numbers here because it's a binomial distribution. So, it was like, but it's yeah, the thoughts there. But it'll always be halves you have over here. This video is getting a bit long. I'm going to carry on in a different clip.